All right, welcome to week 15 practice problems. First question says, which of the following is not equivalent to the sine of negative 45 degrees? All right, so if we're looking at where negative 45 degrees would be, remember negatives, we travel in the clockwise from 0. So this is negative 45 degrees. And remember the sine is the y value. So this is the sine of negative 45 degrees, basically this distance. And we know, if we remember trig stuff, that's negative root 2 over 2. Now I could also show you here, I just did this one, sine of negative 45, as long as I'm in the right mode, right, I have to be in degree mode, is going to give me negative root 2 over 2. Okay, remember 0.707 is root 2 over 2. Okay, so we know that that's true. We verified it with our calculator. So which one of these is not equivalent to? Okay, well, let's see, sine of 40, negative sine of 45. So sine of 45, remember this is our positive 45 degrees. The sine here is the same as negative 45, but it's positive because we go up. When I graph that point, I go up. So that's positive root 2 over 2, but because it has a negative in front, we add that negative and it's the same thing. So this is equivalent to sine of negative 45. So we say that's not our answer. All right, choice B says the cosine of negative 45. So we're back down here, the cosine of negative 45. Notice to get to the cosine, it's a positive because I have to travel to the right of 0, 0. Remember, that's my origin there, 0, 0. So if I go to the right, it's going to be positive no matter what it is. So it can't be negative root 2 over 2. So that means answer choice B is correct. If I checked all three of these, they would all be negative root 2 over 2. The only one that's not is cosine of negative 45 degrees. All right, the lengths of a right triangle are given below. What is the cotangent of angle B? Okay, so remember the cotangent is 1 over the tangent of B. That's the cotangent of B is 1 over the tangent. And remember, tangent is opposite over adjacent. So when I flip it upside down, I get adjacent over opposite. That's what I'm looking for with angle B. So angle B is up here in the top corner. So opposite, that's this one, over adjacent, that's this one. And as you can see from my picture, the adjacent is x. Okay, I just need to find this opposite side. Well, remember, we're dealing with a right triangle. We can always use Pythagorean theorem. So I'm going to call this opposite side just O. Okay, so we're going to say that a squared plus b squared equals c squared. Remember, c is the longest side, it's the hypotenuse. So if I solve for opposite here, I'm going to take away x squared from both sides. That gives me 0 on the left. That gives me the opposite side squared is equal to 25 minus x squared. I went ahead and simplified that 5 squared there. Then to find the actual length of the opposite side, I root both sides because roots and squares cancel out. So I know that this opposite side length is the root of 25 minus x squared. So I'm going to go ahead and write this opposite is root 25 minus x squared. So that when I find the cotangent of B, again, I'm looking at adjacent over opposite, and adjacent is x, and opposite is root 25 minus x squared. So I need to find x over root 25 minus x squared. And it looks like that is answer choice E. Okay, so number 2 is E. So the trick there is realizing that you're missing the side that you need. So you got to use Pythagorean theorem to find out the missing side length. All right, which of the following is not in the domain of y equals secant of x? All right, so remember secant of x is 1 over cosine, right? The one that it shouldn't be. It should be sine, right? Secant and sine, cosine and cosecant, but it's not that way. It's secant and cosine, cosecant and sine. So 1 over cosine of x. If you remember from domain, you're not allowed to divide by 0, right? Numbers that would make you divide by 0 there are not allowed. They're not in the domain. So basically what I want to know is, when does the cosine of x equal 0? Okay, for what values? So remember, the cosine is the x coordinate. So if I'm on my unit circle here, I've got these 4 points where there could be a 1 or a 0. And this location is 1, 0. This one is 0, 1. Remember, my cosine is my x value. So I'm looking to when the x value would be 0. Well, that could be here or here, right? Because this is 0, negative 1. So either at pi over 2 or 3 pi over 2, neither of those would be in the domain. So in this case, we don't see 3 pi over 2, but pi over 2 is listed. So there you go. Now, alternately, we could make sure we're in radian mode, right? Because we're dealing with pi's, we're dealing with radians. And I could just do 1 over, let's see, the cosine of the angles. And we could try pi over 2. Remember, that one is the one that we said is our answer. So when I type in pi over 2, 1 over cosine, it says can't divide by 0. It means it's not in the domain. All the other ones would just give you a value. Okay? So like, for example, what are the other answer choices? You could have had pi over 3. Well, pi over 3 gives you a value, right? 1 over cosine of pi over 3 is 2. So it's allowed to, you're allowed to use pi over 3 in this function. So therefore, pi over 3 is in the domain. So basically, any number you can't use in the function is what we say is not in the domain, and pi over 2 is not in the domain. All right, one boat leaves the marina and travels north at 20 miles per hour. An hour later, another boat leaves the marina and travels at an angle of 100 degrees west of the first boat. If the second boat travels at 10 miles per hour, how far away are the boats from each other an hour later? All right, this is a great time for a picture. Here's our marina. We got this first boat traveling at 20 miles per hour. So every hour it goes 20 miles. And then the other one is at an angle of 100 degrees to the west. Okay, so there's 100 degrees at this angle, and this one goes at 10 miles per hour. Now, if you read the story correctly, it says the first one goes, and then an hour later, the second one goes. So this boat's already 20 miles before the other boat starts. Then it says an hour later, how far away are they? So an hour later, this guy's 10, and this guy here has gone 20, and then another 20, because he actually went for 2 hours. So the distance here is 40. So what we're trying to find is this distance here. This looks exactly like a law of cosines problem. Plus, I mean, look at all the answers. Those look like law of cosines. But one of our A's and B's are 10 and 40. So we should be looking at 10 squared and 40 squared. So this one doesn't have 10 squared and 40 squared. It can't be it. That's not 10 squared and 40 squared. That's not, it only comes down to these two. Okay. Now, what are the differences? One has a minus, one has a plus. Well, if you remember the formula, it's it's b squared plus c squared minus 2bc cosine of a, the angle. That's a squared. So if I square root a, because this is a over here, this thing that I'm looking for, because that's my big angle a. If I square root the a squared, I get the square root of all that stuff. So that's how they're presenting it to me. They're presenting it to me as actually solving for a. So I have to make sure I take the square root, noticing that there is a minus sign in the formula. So answer choice D is correct. Okay, they just want you to set that one up. You don't even have to solve it. All right, if the cosine of theta is negative 0.19, what range of values could theta be? Okay, so first of all, when is cosine negative? Remember, cosine is negative on the left side, because remember, we're talking about the cosine being the x-coordinate. So anywhere you graph on the left side, the x-coordinate is going to be negative. Okay, so that's something you have to be able to know. So really, remember, this is pi over 2, this is pi, this is 3 pi over 2. So the cosine is a very small negative number. So it's not like close to 1. If it was close to 1, your angle would be like this, right? Because if you graph this point, it would be like 0.9, comma, 0.03 or something, right? It would be close to negative 1. Sorry, that should be a negative 0.9 because we traveled to the left. But since it's very small, we know we only went a little bit to the left, and then we either went up or we went a little bit to the left and we went down. So it's either right here or it's right here. These are the only two places where cosine is very small and negative. So could it be between 0 and pi over 4? Remember, this is pi over 4 right here. This is 0. It can't be in this region. That's what A says. So it's not there. B says between between pi over 4 and pi over 2. That's this region here. It can't be that one. This one says between pi over 2 and 3 pi over 4. Well, that's this region right here. And as you can see, that's one possibility. So I think C is the one that we want. D is between 3/4 of a pi and pi. That's right here. It's not that one. And then E is actually this region here between 3 pi over 2 and 2 pi. So it's not that region as well. Those cosines are positive. Now, what if we could use our calculator here? Okay, real quick, I want to write this down. If the cosine of an angle is negative 0.19, then wouldn't you say that the cosine inverse of negative 0.19 would equal the angle theta, right? That's how inverses work. So let's just do that. Let's find the cosine inverse of negative 0.19. Now, since am I in radian mode? Yeah, 1.76 radians, okay? Now remember, usually we're used to pi's and stuff. So pi over 2 is what we're saying between pi over 2. So if I were to say pi over 2, that would be 1.5. So yeah, it's bigger than 1.5, but it's smaller than 3/4. So 3 pi over 4. So it's somewhere between 1.5 and 2.3 radians. And that's what we found out, that it should be 1.76. Alternately, I could change the mode to degree mode and then do the same thing, right? I could go back and say, okay, what's the cosine inverse of 0.19? And it's going to say 100 degrees. Well, 100 degrees is a little bit past 90, but it's not quite 135. So then that, if you're better with degree measures, you can always get your answer in degrees and reason through why that would work. Okay? All right, if the tangent of theta is a over b and theta is between pi and 3 pi over 2, what is sine of theta? All right, so tangent of theta is a over b. Always draw a triangle. Here's your tangent. Oh, sorry, I should draw my triangle in its actual location because it tells me its location, right? Remember, this is pi, and this is 3 pi over 2, 3/2 of a pi, because this is half a pi, 1 whole pi, 1.5 pi. So really, we are in between here. This is our quadrant. We're in the third quadrant right now. So when I draw my triangle, I should draw it like this. Remember, you always connect to the x-axis here. So here's my angle theta, and it says the tangent is a over b. Well, if you remember from SOHCAHTOA, tangent is opposite over adjacent. So when I write that, a over b, that means the opposite is a, the adjacent is b, and then I don't know the hypotenuse. But it looks like I'm going to have to find it, right? Because it asks for the sine of theta. And sine, if you remember from SOHCAHTOA, is opposite over hypotenuse. So it's going to be a over something, okay? Now, if you remember, we're in the third quadrant. So when I actually plot this coordinate point, it's actually going to be at negative b, negative a, right? Because I go left and down. And when we plot left and down, those are negative values. So really, I should put my negative signs here. All right, so I need to know the hypotenuse because I'm supposed to find sine, and it's opposite over hypotenuse. One thing I can actually do right now is say if opposite is negative a, then my answer should be negative a over something. So choice A here is a over something. That can't be it because the hypotenuse is always positive. And so it could be that you have a negative over a negative, but we don't because hypotenuse is always positive. That means it can't be D and it can't be E because it should be A over something. So it's either B or C. Okay, well, how do I find this third side here? Well, I use Pythagorean theorem, right? We make a right triangle here. I know that A squared plus B squared equals the hypotenuse squared. Well, all I got to do is solve for the square root of the hypotenuse squared just to solve for H. And I get the square root of A squared plus B squared. That means the hypotenuse is the square root of A squared plus B squared. And there's my answer. The sine of theta is negative A over the square root of A squared plus B squared. That is answer choice C. You can see choice B is missing that square root part. So we're going to go with answer choice C. All right, a 50-foot tree is placed on a hill such that a person standing at the bottom of the hill sees a 26-degree angle between the top and bottom of the tree. What is the measure of angle A to the nearest degree? All right, so this does not look like a right triangle. You can kind of tell it's not a right triangle. So we can't use traditional sine and cosine and tangent, those opposite, adjacent, hypotenuse. We can't use Pythagorean theorem. None of those things hold. But what I can think about is this triangle like this. I know this is 26 degrees. I know this is a 50-foot tall tree, right? That's the height of that tree. So that's this side right here, 50. I know that this is 75, and what I'm looking for is the angle A. So this is what I'm looking for, angle A. Well, you see how these are across from each other? Whenever you're dealing with angles that are across the way from sides that we know, we always use law of sines. So the sine of A over the length of side A should equal the sine of B over the length of side B. All right, so this is angle B, this is side B, This is angle A, so this is side A. You always deal with the ones across from it. So the sine of A we don't know. That's what we're looking for, but we do know the side across from it is 75. That should equal the sine of angle B, which is angle 26 degrees, over the length of the opposite side from it, which is 50. Now we're solving for side A, sine of A. So we don't have to actually cross multiply here, because the thing that we're looking for is on top. Anytime you have a fraction equal to a fraction and you want to find the thing on top, you multiply out the bottom from the side that you want to solve for. So we get rid of that. We end up with the sine of the angle A is the sine of 26 divided by 50 times 75. Okay, well, that's not A by itself. Remember, I can't divide by sine. That doesn't exist. You're not allowed to divide by sine. What we do to get rid of sine is to take the sine inverse. So I'm going to take the sine inverse of this crazy looking thing on the right side, and that's going to be what A is. A is the sine inverse of all this stuff. So I have to use my calculator here. Okay, first of all, am I dealing with degrees or radians, right? Measurements are in degrees, so I need to make sure I'm in degree mode. If I'm not in degree mode, it's going to totally mess things up. So I am. All right, so inverse sine, I always like alpha y equals enter to make a big fraction. And then what did I have here? I had sine of 26. So sine of 26 times, or excuse me, divided by 50. Okay, divided by 50 times 75. Times 75. Close the parentheses, hit enter, 41 degrees, 0.11, 41.11. It says round to the nearest degree, so 41.11 is closest to 41 degrees. So answer choice D is correct, 41 degrees. All right, what is the period of the function y equals 3 cosine of 2x minus 6? All right, so man, I'm telling you, cosine functions, we know the period is always 2 pi over b, and b is the coefficient of the x term. So this is just 2 pi over 2, and when we have a 2 on top and a 2 on bottom, they cancel, so the period is pi. That one's just pretty easy. Now alternately, let's say we didn't remember the formula, right? This might be a great time to graph. So I go to the y equals here, and I'm going to graph my function. So 3 cosine of 2x, oops, 2x minus 6. Double check that I input it incorrectly. Sure did, I hit graph. Now with things look weird, always zoom 7, right? There we go. Now look, my window's a little bit messed up. I want to see lower. So it says it goes down to 495. I must be in degrees, which is okay. I just need to go smaller on my x minimum. So let's go to x equals negative 1,000 degrees. When I look at it, oh, I still don't see it. What am I looking for? The period. So really, actually, I just need to find the top to the top, the distance from the top to the top. So if I look at my table, now these, it's in degrees, which is a little strange. So actually, I'm going to get out of degree mode. Radian mode makes things a little smaller. Degree mode, things get huge. So here we go. Now that I'm in degree mode, go back to y equals and graph. And then I'm going to have to do zoom 7. That's zoom trig. There we go. So now I need top to top. That's the period. So when is it at its maximum? Looks like its maximum is negative 3. So negative 3 is the highest this function actually goes. Those other numbers are bigger negatives, which mean they're lower. So how long does it take to go from negative 3 all the way down and then back up to the height of negative 3? Well, it starts at negative 3. It's at a height of negative 3 at 0, and then it's at negative 3 again at 3.14. So it takes pi. That means the period is pi. Okay? But again, we already knew that. So all I did was, is I looked at my function and I measured the distance from one top to the next top. Remember, I can always measure tops to tops or bottoms to bottoms. If you do middles, you got to skip one and go to the next middle because it has to go through a full cycle before it gets to that next middle. But either way, I'm just using my table to measure the distance from top to top. Okay? All right, how many radians are there in 36 degrees? All right, so we're given 36 degrees. We want to end up in radians, which means I need degrees to cancel. and I need radians on top, right? I want the degrees to cancel. That means I need 180 because that's the number of degrees in half of a circle. And we know there's pi radians in half a circle. So there we go. Degrees will cancel with degrees and leave me in radians. All I have to do now is calculate what 36 times pi divided by 180 is. Now, if you look at my answers, none of those are in decimals. So if I were just to get my calculator out here and do 36 times pi and then divide that by 180, what I'm going to get is a bunch of stuff that doesn't have the decimals, 0.62. Like, none of those look the same. Although I could go through each of those and do pi over 12, pi over 6, pi over 5, pi over 4, 2 pi over 9, and see which one of those equals 0.628, then I would have my answer. That wouldn't take me very long. But really, if I just think of the fraction 36/180ths as my number in front of my pi, I just simplify this fraction. So I can do that on my calculator. 36 divided by 180. And I hit enter, it gives me a decimal. Now that's 1/5. If you don't remember that, math, enter, enter. 1/5. So that means we really have 1/5 of a pi. And the way that we write that is we write the pi on top. So pi over 5. That is 1/5 of pi. So answer choice C is correct. All right, in the triangle XYZ, angle X is 34 degrees, angle Y is 61 degrees, the length of XZ is 35. Set up the equation that would be used to find the measure of side XY. All right, this makes no sense to me unless I have a picture. I just don't quite get what's going on here. So I draw a little picture, triangle XYZ. Angle X is 34 degrees, so 34 degrees. Angle Y is 61 degrees. And then it says the length of XZ is 35. So I'm going to mark that as 35 units. So what are we looking for here? The side length XY. So we're looking for this side here that I'm going to draw a nice bright pink. That's what we're looking for. Okay. So how do I find the side length of that? Well, I guess it looks like I have a pair of opposite sides and angles. And then I have this pair that I'm looking for. So we could call this N because it looks like in all my answers they're calling it N. That's the side length there. But I don't know this angle Z. But if you remember from all triangles, we know two angles. We should know that we do 180 minus the sum of those two. So 34 plus 61, that's 95. So remember there's 180 degrees in every circle. We already used up 95. That only leaves 85 degrees left over. So we do know angle Z because we know the other two angles. Okay, so remember, use the ones that are opposite of each other. So the sine of angle A, or Z, I guess in this case, which is 85 degrees, divided by the side length associated with it, so the one across the way. That should equal the sine of angle Y, which is 61 degrees, divided by the side length opposite of it. And that's it. Sorry, I just realized that you can't see this. I'm going to rewrite it down here. Sine of 85 degrees divided by n equals sine 61 divided by 35, right? 35, the angle is 61, the opposite side is 35. That's why they go together here. And then here, 85 and n go together because they're opposite of each other. And just make sure the angle is the one with the sine and the length is on bottom, okay? So the only one that matches is answer choice B. All right. All right, the cosine of theta is -4/5, and theta is between pi and 3 pi over 2. Find the cosecant of theta. All right, first of all, it says we're in the third quadrant because we're in between pi and 3/2 pi. Remember, this is 0, this is a half of pi, this is pi. So we're at half a pi, pi, 3/4 of a pi, 2 pi. Okay. So here we are in this region here. We're in the third quadrant, so that's where I want to draw my triangle. Remember, you always come 90 degrees to the x-axis. And it says the cosine is -4/5. Well, remember, cosine is the adjacent over the hypotenuse, right? We know that from SOHCAHTOA, right? Cosine is adjacent over hypotenuse. So here's the opposite side, here's the adjacent side, and here's the hypotenuse. Okay, so it says it's -4/5. So -4 and 5. Now remember, that could be 4 over -5, but which one of these can it not be? The hypotenuse is always positive, so it can't be this one because the hypotenuse would never be -5. So it tells me the hypotenuse is 5 and our adjacent is -4. So we go over 4 and then it's 5 on the diagonal. Well, how do I find the opposite? That's kind of the whole point. We usually have to find this third side. Well, I could use Pythagorean theorem. A squared, so the opposite squared, plus b squared, which is 4, or you can use -4, doesn't matter, but you square it, it equals the hypotenuse squared. So the opposite side squared plus 16 equals 5 squared, which is 25. Take away 16, we get the opposite side squared is 9. When we square root it, we get that the opposite side equals the square root of 9, which is 3. Now remember, this is -3 because when we plot this coordinate, we are at -4, -3. We actually go over and down. And when we go down, we always go negative, right, when we're plotting points. So we remember both of those are actually negative numbers because we're in the third quadrant. Now remember, this is a 3, 4, 5 triangle. We should know that that was -3 almost instantly. If we're really paying attention and understand 3, 4, 5, and 5, 12, 13 right triangles, it should almost be instantly that we get that. Okay, now all we got to do is answer the question. So here's our angle theta. It says, what is the cosecant? Remember, cosecant is 1 over sine. So all you got to do is find the sine and flip it upside down. Well, sine is opposite over hypotenuse. So when I flip it, it's hypotenuse over opposite. That is my goal. Hypotenuse is 5, opposite is -3. So 5 over -3, which is -5/3, right? A positive divided by negative makes a negative overall. And so answer choice A is correct. All right, find the sum of the solutions of sine of x equals √3/2. And x is between 0 and 2 pi. Okay, so the sine is the y value, and the y value is √3/2. So here's one location where the y value is positive √3/2, and here's your other value of y, it's positive √3/2. So what we're looking for is this angle here, right? And then also this angle that gets us to here. Those are the two solutions, those angles, because right, we're solving sine of x equals a value, we're looking for an angle. So let's try the calculator first. Remember, we know that sine of x is √3/2. If sine of x is √3/2, how do I find x? Well, I inverse sine both sides, right? Inverse sine kills off sine, and x is the inverse sine of √3/2. So when I type that in my calculator, the inverse sine of √3/2, 1 degree. Does that make sense? Are we at 1 degree? 1 degree is like right here. You can barely even see it. It's just one little degree. That doesn't make any sense. What could it be going wrong? Obviously, I'm in the wrong mode, right? We're talking about degrees here. Okay, we're measuring this in degrees. Well, actually, because it says between 0 and 2 pi, maybe you could think of it as radians. And our answers are in radians, so maybe this isn't such a bad idea. Maybe we'll stick with that radian measure. Okay, let's see here. So 1.04 radians. Well, what is that as a fraction? Well, it's usually pi over something, so let's check it out. Pi over, let's try 4. No, that's too small. So we need to divide by a smaller number. How about pi over 3? There we go. So pi over 3 radians is this location. Pi over 3 radians. We have to add that to whatever this is. Now this is the kind of the hard one, because if you're not really familiar with trig, this can be kind of tricky. What you have to remember is it's symmetric. So if we're thinking of it in degrees, this is 60 degrees. Now let me show you why that works. Remember how we changed modes? Well, now if I do the inverse sine of 3 pi over 2, actually what I'm going to do is just go up here and type it in because I already have it worked out. It says it's 60 degrees. So if I look over here, it's 60 degrees up here. Well, that means it's 60 degrees back from here. That means, what is this, 120? Means it's 120 degrees. So there we go, 60 degrees and 120 degrees. If I add those two solutions, I get 180 degrees. Now, a couple choices here. I could convert that. Remember, we go from degrees to radians by multiplying by 180 over pi. 180 cancels, we're left with pi radians. That's our answer. Now, alternately, if you really know your trig, you know this is 2 pi over 3. When you add 2/3 plus 1/3, you get 1 whole pi. A couple ways to do that, but just remember the symmetry of this unit circle. If it's 60 degrees up here to a solution, and the same y value should be 60 degrees up this way, just remember that's 180 minus 60 is 120. So you can use that symmetry to help you out there as well. All right, which of the following is a solution to 2 cosine squared theta plus cosine theta minus 1 equals 0? All right, well, first of all, right, what it means to be cosine squared theta means cosine of theta squared. It's the same thing. You can either put the 2 inside here or you can bring it out front. The reason we like to think of it out front is because I'm about to factor this thing, and it looks a little more normal if I factor it where the squared is out front here, kind of outside the parentheses. So remember, this works the same as x's. So I could do 2x squared plus x minus 1 equals 0. How would I factor that? Well, it would be 2x times x, and this would be 1 times 1. You could play around with the signs, but to get a negative 1 by multiplying this 1 and this 1, 1 has to be positive, 1 has to be negative. You could try messing around with the signs. That gives me negative 2x, and plus x, that gives me negative x total, which is wrong. We don't want to do that. So that means our signs are backwards. That means I want to have a negative here and a plus here. Okay. If you're not sure about that, go back and look at some factoring. These things should be pretty easy if we're good at our factoring. So remember, we don't do that because we're really dealing with cosines instead of x's. So what that means is it's 2 cosine of x minus 1 times cosine of x plus 1. You see the similarities between this and this? It's just the same thing with, instead of x's, we put cosine of x. We can use x's to see how to factor it because we're more comfortable. But once you get used to it, you're like, oh yeah, this is pretty straightforward. Okay, well, remember this is equal to 0, so that means each of these should equal 0. So 2 cosine of x minus 1 should equal 0, and the cosine of x plus 1 should equal 0. Now, if I solve for cosine of x here, I add 1 to both sides. That gives me 1 equals 2 cosine of x, and then I divide by 2. So I'm solving for the cosine. Cosine of x is 1/2. And over here, it's pretty straightforward. The cosine of x is negative 1. I just subtract 1 from both sides. Okay, so I'm going to use a nice bright color here to highlight where I'm at. So these are my 2 answers. I just need to figure out when that happens. So, you know, I'm thinking, when is the cosine of x equal to 1/2? Well, if you know your trig, you should know that answer pretty quickly. If you don't, pop over here and do the inverse cosine. Remember, inverse cosine of 1/2 is going to tell us the angle at which this happened, and it says it's 60 degrees. Now remember, we're in pi over 2s and pi over 3s and all that stuff, so the fact that I got 60 may not help me, but remember, I can convert that by multiplying by 180 over pi, and 60 and 60 cancel, and that's really 60 times 3, so the 60 cancels with the 60. Leaves me with 3, so pi over 3 is my answer here. Over here, when is the cosine equal to negative 1? Again, I can do inverse cosine of negative 1, and it's going to tell me that it happens at 180. If you're good with your trig, you'll know that already. So 180 degrees, remember, we can multiply by pi over 180 to really calculate what that is, and that's pi radians. There we go. So pi and pi over 3 are 2 of my solutions. So I see pi over 3, and that's one of them, so that one works. Okay. All right, a couple things here. I could use guess and check. I could plug in pi over 2 for theta, and I could say, what's 2 cosine squared of pi over 2 plus cosine of pi over 2 minus 1? Does that equal 0? Question mark. And see if it works. If it works, then you got a solution. If it doesn't work, that's not one of your solutions. All right, the way I really like is to solve an equation. This is an equation using graphing techniques. Okay, we're going to use graphing techniques. So I go to y equals, I graph the function, the left side and the right side. So sorry, 2 cosine of x squared. Hopefully this will let me work. Yes. Plus cosine of x minus 1. All I did was I graphed the left side of this equation, right? I graphed this whole thing here. Remember, this is how we use our graphing technique. Graph the left side, graph the right side, find the intersection. So I graphed the left side, Then I come down here and I graph the right side, which is 0. Then I hit graph. All right, now I better hit zoom 7 because I'm in a trig thing. There we go. All right, we see all these intersection points here, here, here. Well, what is this right here? We want to find the intersection. So second, calculate number 5, enter, enter, enter. And this says 60. As you can tell, I'm in degree mode. Okay, so again, I could take that and I could convert it. Right, I take my 60 degrees just like I found here. I do times pi over 180. I get pi over 3. All right, alternately, you could convert it to radian mode on your calculator, but it's going to give you whatever pi over 3 is. Let's look at that. If I change it to radian mode and I graph it, remember every time you change modes, you got to go back to zoom 7 to fix it. All right, so second calculate number 5, enter, enter, enter. So 1.04. All you got to do is say, well, 1.04, what is that in radians as far as pi's go? Well, just go back to your regular mode here, pi divided by 3, and you're like, oh, that's 1.04. Okay, good, it's pi over 3. So a couple different ways to work that problem. All right, in triangle ABC, what is the value of secant of A times cotangent of B? Okay, so there's 2 different angles in this problem. There's angle A and angle B. So what you have to realize is that from angle A's perspective, this is the opposite, this is the adjacent, and this is the hypotenuse, okay? Now when we look at angle B's perspective, those opposite and adjacents are actually going to switch. The hypotenuse stays where it's at. So let's think, we're looking for the secant of A, and if we remember, the secant of A should be 1 over the cosine of A, and the cosine of A is adjacent over hypotenuse. So when I do 1 over adjacent over hypotenuse, sorry, this is adjacent over hypotenuse on the bottom there, so you can see it, we flip it, so we get secant of A is really just the hypotenuse over adjacent. So from A's perspective, the hypotenuse is x, and the adjacent is z. So the secant of A is x over z. Okay. Sorry, that's a z. That doesn't look like a z, does it? All right, so let's use a different color here. From angle B's perspective, we're not dealing with the opposite and the adjacent as we had from angle A. This is our opposite now because it's on the opposite side. This is our adjacent side. So from angle B's perspective, we're looking at the cotangent of B, right? That's what it says here. We're looking for secant of A times cotangent of B. Remember, cotangent is 1 over tangent, and tangent is the opposite over the adjacent. So when we flip that, we get adjacent over opposite. So adjacent is y divided by opposite, which is z. So y over z is the cotangent of b. So when I put it all back together, I get the secant of A times the cotangent of B. That's what I'm looking for. And we found the secant of A was x over z, and that the cotangent of B was y over z. So we want to multiply those. Remember when we multiply fractions, multiply across the top, x times y, we write as x times y. Z times z, we write as z squared. Okay, and that is answer choice A. xy divided by z squared. There we go. All right, what is the value of -2 sine of 3 theta plus 2 when theta equals 45 degrees? All right, so we're evaluating here. They give us an expression and they tell you the value of the variable and we're supposed to plug that in. So we just need to find -2 sine of 3 times 45 degrees plus 2. So that's, let's see, 3 times 45 is 135 degrees. All right, so if we're really good with our trig, we know that 135 degrees gets us to here. The sine is root 2 over 2. If we're not so good with that, we could get over to our graphing calculator and just calculate the sine of 135 degrees. Am I in degree mode? No, I'm in radian mode. That will give me something totally strange. So I make sure I'm in degree mode. Sine of 135 degrees is 0.707, which is root 2 over 2, right? We've got to memorize that. 0.707 is root 2 over 2. Okay, so either way, -2 times root 2 over 2 plus 2. Well, remember this 2 and this 2 cancel because one's multiplying, one's dividing. And that leaves us with negative root 2 plus 2. So that's our answer. Now, if I'm looking at all my answer choices, it looks like they've actually flipped it to where it's 2 minus root 2. It's okay to flip that addition around. So there we go. Answer choice B is correct. All right, the following angle theta is shown in the third quadrant. Which of the following is true? All right, so it looks like we're at the coordinate -3, 4. So here's our triangle. This is -3, this is -4. And then, of course, 3, 4, 5 triangle, you could confirm that is 5 using Pythagorean theorem, right? A squared plus B squared equals the hypotenuse squared, or C squared. You get 9 plus 16 is the hypotenuse squared, that's 25. Square root both sides, you get 5. But we should kind of be getting this at this point, that this 3, 4, 5 triangle thing exists. So in our big triangle here, I'm just going to highlight this. Here's our angle theta. The sine, it's saying the sine is -3/5. Remember, sine is opposite over hypotenuse. Opposite is -4, hypotenuse is 5. That means the sine is -4/5. Is that what it says it is? Nope, it says -3/5. So it's not A. All right, cosecant, remember that cosecant is 1 over the sine theta, and sine is opposite over hypotenuse. So that means 1 over opposite over hypotenuse is hypotenuse over opposite. Let's see, hypotenuse is 5, opposite is -4, so 5 over -4. Well, it says -5/4, and we know it's 5 over -4. These are the same thing, right? You just pull that negative out front. You can either have it on top or on bottom or out front. They all mean the same thing. So answer choice B is correct. Cosecant of theta is -5/4. All right, find the solution to the equation cosine of 3x minus 15 equals 1/2. Assume that x is between 0 and 90 degrees. All right, so we know that the cosine of something equals 1/2. Anytime we have this parentheses and we're looking for the angle, we always do inverse cosine of both sides, right? That's just what we do. Inverse cosine cancels and leaves us what's in the parentheses. And if I get my graphing calculator out and I say, what is the inverse cosine of 1/2? It's going to say 60 degrees, right? Remember, I'm in degree mode. So whatever this angle is, it's 60 degrees. Now, what was in there was a 3x minus 15, okay? So I should have had a 3x minus 15 in there. I'll go ahead and fill that back in. So we know that 3x minus 15 is equal to 60 degrees. So how do I solve that? Well, I add 15, okay? That goes to 0. We're left with 3x equals 75. If I divide both sides by 3, I get that x is equal to 25 degrees. There we go. Answer choice C. Now here's what I like. First of all, you could easily plug and chug. You could plug these into here and see which one works and see which one doesn't. Guess and check would work just fine here. Or we could use this graphing technique, right? This is an equation. We can always solve equations using this technique. So graph the left side, graph the right side, find the intersection. So here we go. We're going to graph the left side. Cosine of 3x minus 15, and the right side was just 1/2. So I'm going to graph these. When things look weird, zoom 7, right? Here we go. So we're saying between 0 and 90. So that looks like between here and here. Where do they intersect? It looks like they intersect right here, this little intersection point, okay? So what we want to do is we want to do second trace, number 5, the intersection. And we choose the two graphs, and then we make a guess. So I can pop over here to where I think it is, and it says, yes, 25 degrees is the intersection. Remember, don't care about the y. All we care about is the x coordinate. Okay? Very good. All right, a person is standing such that his two friends are 150 degrees apart. One friend is 25 feet away while the other friend is 40 feet away. Which expression represents the distance the two friends are away from each other? All right, great time for a picture. Looks like there's 150 degrees between them. One of them is 25 feet while the other is 40. And we want to know what is the distance between our two friends. So we want to know this right here. Well, that's A, right? This is angle A, this is B, and this is C. We're dealing with definitely a law of cosines. So remember, law of cosines says that A squared is B squared plus C squared minus 2 times AB cosine of the angle A. And then, of course, when we square root both sides, we get that A is just equal to the root of B squared plus C squared minus 2AB. So remember, B and C are 40 and 25. They all look like that, right? If you look at all the answer choices, they all have this B squared plus C squared part. What they don't have is a cosine. You notice how at the end, none of these have a cosine in them, which means they evaluated the cosine. They actually found out what cosine of 150 was. So let's plug this in here. We should get 25 squared plus 40 squared, although that's not really the important part, minus 2 times 25 times 40 times the cosine of the angle, 150. Well, what is the cosine of 150? I can get out my calculator here, and I can find the cosine of 150. Okay, looks like I'm in degrees. So the cosine is negative 0.866. Remember, that is root 3 over 2, right? We memorized that earlier. So negative root 3 over 2 is what goes right here. So if I have negative, instead of this, I'm going to go ahead and erase it. All right, instead of this, I have negative root 3 over 2. So what happens? Right, none of these have a 2 in front. If you look at the answer choices, what happens is the 2 cancels with the 2 on top and the 2 on bottom. Now, some of these have minuses and some of them have pluses. Some of them have root 3s, some of them don't. Well, this root 3 exists, so it's going to be A or B. The question is it plus or minus? Well, it says minus right here, right? So I'm thinking, oh, it's got to be minus. But look at this negative root 3. That negative sign pops out front and combines with that other one, because it's this times this times this times this times this. You multiply that negative out front, it actually changes it to a plus sign. So I think we're going to go with answer choice B, the one with the plus sign and the root 3. All right, in a right triangle, angle x is less than 90, angle y is less than 90. If cosine of x is 5/13, what's the value of the tangent of y? All right, first thing, we better draw a triangle here. It's a right triangle. Now, why does it say x is less than 90? It's just telling you that this angle can't be x, right? It has to be an acute angle, so this could be x. Same thing for y. It's telling you where z is. Z is the right angle because x is acute and y is acute. All right, so if the cosine of x is 5/13, right? Cosine of x is 5/13. Well, remember, cosine is adjacent over hypotenuse. So I better label this triangle here. Adjacent is 5, hypotenuse is 13. If we remember correctly, that means 12 should be our other angle. Remember, what we're doing is 5 squared plus x squared equals 13 squared, and we're realizing that when we solve this Pythagorean theorem, we get 12 for x, okay? All right, now what's the tangent of y? Now notice they switched the angles on us, so when we're dealing with tangent, we need to label opposite, adjacent, and hypotenuse, and tangent is opposite over adjacent. So 5 over 12. So the tangent of y should be 5/12. So answer choice D is correct. All right, how many degrees to the nearest whole number are there in 1.7 radians? Well, if we're in radians and we want to convert into degrees, all we do is multiply by this conversion constant, right? Degrees over radians, because I want radians on top, radians on bottoms to cancel. That will leave me with degrees. Then I fill in the numbers. Well, there's 180 degrees for every pi radians. So all we need to do is 1.7 times 180 divided by pi. It's easy on my calculator, okay? Now it does say to the nearest whole number. So when I get this answer, I'm gonna round. So 1.7 times 180 divided by pi. 97.4, so the nearest whole number is 97. So that means B, 97 is correct. All right, thanks for being here, guys. We will see you next week.